is recording. All right, welcome back to another video on 1MO3, structure and property of material. Today I'm very excited because I've dreamed up of a game for you to actually play with me together. Before we play this game, the learning objective of this video is about what is material property. So previously, you might have already learned that different structure and different devices are made out of different materials and they serve different functions. So for example, if you look at this here, looking at this graph, you have so many different materials, different type of object that you can touch and sense in daily life, and they are made out of different materials. So why? Well, because they are made out of, they have different material property. So property is something that's very similar to performance, at least qualitatively. So in this particular lecture, we'll go in more details about what is material property. But before we go into that, I want to give you an intuitive sense about what is material property. So instead of giving you a definition, let's play a game. And the game that I've created is called Material Taboo. So perhaps you might have heard of the game Taboo, which is you can guess something and you are not allowed to say the name of that particular thing. Okay, so similar here, we have 12 balls, and I'm just going to unshare the screen for a second. You should be able to see that, hello, right in front of me, there's a list of materials or list of balls made out of different materials. I also have a fridge magnet that I can use to verify if material are have magnetism or not. Anyway, so for the last few months, I've collected these balls. They are all made out of different material, and it has the same diameter. So this is very important. They all have the same diameter, such that I can fairly evaluate them without worrying about bigger things may be heavier. Okay, by making sure all these balls have the same diameter, I can now tell you each of the material what is the weight. And so right in front of me, I'm going back to the slide. Right in front of me, I have a list of materials. On the very left of that graph, we have a very light material. We have styrofoam, we have wine corks, and then in the middle we have polyurethane. Polyurethane is a ball that can be quite bouncy. So it's an elastomer material and it bounces around. Okay. Polypropylene is another type of hard plastic and it doesn't bounce around. We have wood, we have glass. So these are in the middle. And we also have aluminum alloy that are in the intermediate weight range, in between 10 to 20 grams. If it were in person, and if you were in my class, you will be actually measuring the weight with me on each of these balls. But to save some time and the trouble, I have already weighted that for you, and they are in this qualitative scale. On the heavier spectrum, we have mild steel, we have stainless steel, we have brass, we have copper, and we have a ceramics material called alumina. Okay, so you might ask, what is mild steel? What's the difference between stainless steel and mild steel? Well, mild steel tend to rust, and stainless steel doesn't. Brass is an interesting copper alloy. You add zinc into it, and it actually makes this beautiful golden color. And so a lot of people use that to make jewelry. And then you might ask, well, what is this alumina here? It's a ceramics, and it's basically aluminum oxide. So if you oxidize aluminum, and you can make a ball out of it, that would be this ceramics ball. So again, lightweight materials, medium weight materials, heavy materials. So in this game, I have 12 balls in front of me. they all have the same diameter. If we were in person, we can pick and choose a random materials. But in this particular game, in this asynchronous video, I have already picked one material in my mind, and I want you to guess what is that material that I have already picked or chosen, okay? And I've scripted 7 questions for you to describe these materials without giving away the material name. That would be the taboo of this game, okay? So in this educational game, go with me and try to guess this materials. What would be that material that I have in mind? And hopefully through this exercise, you'll get a sense of intuition of what material property is, okay? So let us begin. So just a review, this is the material property. So question 1, how heavy is this ball? I'm actually holding it right in front of me. I've already weighted it. And the ball that I have chosen is on the relatively heavy side, okay? So hopefully that already helped you to eliminate 2/3 of the ball in the spectrum. So this is a relatively heavy ball, okay? You might want to ask yourself after this lecture, why one material is heavier than the other? What is that material property? What caused that material property to arise? Okay. Question 2. If I drop this ball onto the table, will it make a loud pitch or will it also make a high pitch noise? So quiet or loud, a low pitch versus loud and high pitch. B. So I have a ball right in front of me. This is the chosen ball. I'm going to drop it. You're not going to see it, but hopefully my mic will pick up the sound. I'm actually dropping it onto a coaster. So it's loud, it's high pitch. So loud and high pitch. So loudness may be helping you to get an idea of what kind of density this material might be. And high pitch might mean the vibration of that particular ball when it hit the ground. So it's loud, and you might want to ask why it is loud. How bouncy is this ball? You heard it. It wasn't very bouncy. It didn't bounce multiple times. It dropped once and make a very small bounce. So I would call this not bouncy. Okay, so maybe hopefully that will help you to eliminate at least bouncy ball. If I hold it on to my hand, does it feel cool? And I want you to think about that. All these balls has been sitting at the room temperature for a very long time. So they're all at room temperature, 25 degrees. And my body temperature is 37 degrees centigrade. And I'm touching this ball and it does feel cool. But what makes this material cool versus the other materials? What is that property? So the answer is, for this question, is it is a cool material. It's cool to touch. If I touch it long, by the way, it will bring back to the room temperature. It will start to feel like a room temperature. So what's the problem? What's going on here? What caused this material to be like that? Finally, does it stick to a magnet? So I have a fridge magnet. I'm going to try it now. It has no sticking. It does not stick to the magnet. So no, it is not. So question 5. No, it has no magnet. So use magnetism. So think about this. What would that material be? Question 6. What color is this ball? The color of this ball is silverish. So it's not white, it's not rice color, it's not brown, not yellowish, not transparent, silverish. So what material could that be? Question 7. Name one typical application of this material. So this material can be used actually in multiple applications. It's used in structural application quite a lot. And for this particular question, it's not often used in food packaging. It's very often used in kitchen sink. So you might want to think about what's the function of a kitchen sink, what kind of adjective you want to be having it to be. Sometimes it's used in railroad. Sometimes it's used in aerospace, less often. It's not used in aluminum soda can. It's not used in electrical wire. Saxophone, not really. Electrical insulator, no, and not less, and it's not. So the typical application is kitchen sink. So hopefully this gives you an idea of what this material might be. So let's just go through this. Heavy, loud and high pitch when you drop the ball, not bouncy if you drop the ball. When you touch it, it feels cool. It does not stick to a magnet, and it's silver color. So, and the application is kitchen sink. So thank you very much for watching this video. In the next video, I will review what I have chosen to be the materials. Now, I hope you to review this 7 questions and ask yourself, what do you think is the most appropriate material for those 7 questions? Thank you.